Hello, my name is Sumang Liu. I'm a JS developer with a background in geodetics and cartography. Today I want to show you a small application I developed 3 years ago. It is a tourism information query system with routing functions. It might not be the best and most functional JS application I've ever developed, but I want to show you this application for two main reasons. First, this development is a infrastructure level development. I didn't use any DGS developer kit such as Google, ESRC engine, MapInfo, MapX. No, the only thing I used was Visual Studio C++. That means I have to define my own spatial data structure, the spatial data model, the network structure, and so on. The second reason is this project does not only cover the software development part, it also covers the data part. I actually did the data digitizing, the data preparation, and the topology construction, the network construction, and so on. So let's get started and see what we can do with this small application. When we start this application, we see a BMP base map. The base map is actually just an image. We can zoom in, zoom out. I wrote these zoom in, zoom out functions, and the point zoom in, the rectangle zoom in, the pen. These are the basic data, and these are the basic map viewing functions and for extent. But this is just image. It doesn't have any spatial information in it. So the first thing I do is to digitize the main buildings in the summer palace. And after digitizing, it is in that way. I use the rectangle to represent the buildings, and I use lines and the nodes to represent the road network. So after digitizing, we put some attribute information into it, and we can do the query. For example, this is the Chang'an Palace, this is the Taihe Palace, this is the Wu Gate, and so on. And I put all the spatial features into two main categories. The first category is the tourism places. It contains the three main palaces, the living buildings for the emperor, the living building for emperor's servants, the four gates, and the bridge. And the other main category is facilities. There is ticket office, restaurant, and the retailer store, and so on. So let's go for, so when we have all this data, we want to do some spatial analysis. The simplest spatial analysis I implemented is to find the nearest facility place for each tourism place. For example, if we stand in front of Donghua Gate and we want to find the closest restaurant, Donghua Gate is here, restaurant is here, or we can pick whatever we want. If we stand in front of, say, Jiaigong, and we want to find the closest ticket store, this is Jiaigong and this is a ticket store. So this nearest facility function is based on network distance rather than Euclidean distance. And then we have the shortest path functions. We can click on the main tourism places or facility places and see the shortest path between them. For example, if we want to go from here to here, or if we want to go from Taihe Palace to, for example, this place, or we try a further one if we want to go from this gate to here. This shortest path algorithm is Washoe-Floyd shortest path algorithm. You may wonder why I chose this algorithm because it is not very time efficiency. The big O time complexity for this algorithm is n3 power. N is the number of nodes in the network. I chose this one because I was taking the discrete mathematics course at that time, and we were actually learning this algorithm at that time. So I thought, okay, why not just implement it and try it by myself and put something from book into practice. Later, I learned some other routing algorithms, just like the A-star algorithm, the Dijkstra algorithm, but this one was the first shortest path algorithm I've ever implemented, and it worked. This is the shortest path between 2 points. Sometimes the visitors want to go different places, and they do not know which place to go first, and they do not know what is the best way to go there. So we have another function called the shortest tour path for the visitors. And working that way, we can randomly pick 1, 2, 3, 4, maybe 5. We pick 5 places, and we say yes, and it will ask the visitor whether he wanted to come back to the starting point or not. The starting point for this system is the Wu gate, because this is the entrance of the summer palace. So the visitor can choose either yes or no. Let's choose yes first. So we want to come back to Wu gate. We start from Wu gate to our first stop, the second stop, the third stop, the fourth stop, the fifth stop, and the final stop. Come back to Wu gate. Or we try another one. 1, 2, 3, 4. Okay, yes, and we still want to come back to the Wu gate. From Wu gate to our first stop, second stop, third stop, fourth stop, and come back. And sometimes the visitors do not want to come back, they just want to go forward. So there is another, we can do it for the users. We pick 1, 2, 3, 4, 5, say yes, and it will ask you whether you want to come back or not. You say no. So this is your first stop, second stop, third stop, fifth stop, fourth stop, and fifth stop. This function is based on the k nearest neighbor algorithm of Hamilton tour. And we have 3 functions to implement it. And we also have some predefined path for the visitors. For example, this is the predefined path 1, predefined path 2, 3, and 4. So yeah, this is generally speaking, this is how we make it. And the most difficult part is to set up the topology between this neural network, because when we digitizing this neural network, I can draw a line from here to here, and then I draw a line from here to here, but how can I tell computer that these 2 lines are actually connected? So I set up my own topology and to detect the connectivity between points. And based on this topology, we run the Washoe-Floyd algorithm for the shortest path, and then we base our shortest tour path functions on these shortest path. So this is one of the infrastructure level development I have done, and I agree that the interface is not that good, but this is just a this is just a small game I made for myself. And thanks for your interest. If you want to know some details about this application, I can share you all code, sample codes, and data. And if you want to know more about my programming projects, I have my websites, and you're welcome to visit. Thank you.